Welcome back. Let's do question 10c. In the diagram alongside quadrilateral CABD is drawn. AC is parallel to BD. And then BD is equal to P. And then AC is equal to M. Then angle ABC is equal to beta, not theta, beta. And then angle BCA is equal to theta. I prove that M times sine beta cos theta plus sine theta cos beta is equal over sine beta is equal to P over cos theta. So we need to prove this. So before we start solving or working on this problem, we need to really understand the information that we're given and how we can approach this problem. Okay, let's just discuss. If we check here, we're given this quadrilateral, which is divided into two triangles. If you check, we have triangle ABC. This is triangle ABC, this triangle. Okay, and then this triangle, you see that is not a right angle triangle. You see that it's not a right angle triangle. And then we have triangle BDC. This one, this is another triangle, triangle BDC, which is right angle triangle. When are given problems that involve triangles that are not right angle triangles, you think of the cosine rule, sine rule, and the area rule. Okay, right. If you check here, we have M over sine beta, which may be coming from this side and this angle. So here we can see that we have to use the sine rule for triangle ABC. And then for triangle BDC, it's a right angle triangle, so we can use our simple trigonometric ratios. Okay, tan theta, cos theta, sine theta. Okay, so we have a common side, which is BC. So the first part will be to find BC using triangle ABC. And then we find BC using triangle BDC. And then if we equate those two equations, and then we're going to what? To find this. Okay, right. So we're told that BD is parallel to AC. So think of the geometry of parallel lines, alternate angles, corresponding angles, and cointerior angles. But here we're going to definitely talk about the alternate angles here, because we have alternate angles that alternate. They're on different sides of the transversal there. So this angle here is also theta. You see that? Okay, right. What else do we need? Oh, we have the side and the angle here when we're talking about a triangle ABC, but this is side BC. Let me just write it here because I know it's BCS, but let me just highlight it here. Right. So we also need this angle here. This angle here. So how can we get this angle? Can get this angle from beta and theta, because triangle ABC, okay, this is a triangle ABC, which we can find the interior angles of a triangle. So using the interior angles of a triangle, we can find what? We can find this angle A here. So this angle here is going to be angle is, let's find it, angle A is equal to 180 degrees minus angle beta plus theta. Why? This is what? Angle sum in triangle. So this angle here is 180 degrees minus beta plus theta. Okay, right. And then this one we talked about it, angle B there, or angle DBC is equal to theta, since we have alternate angles. AC is parallel to BD. Okay, so this one is angle theta. Now let's find our BC using triangle ABC. Let's find BC using triangle ABC. This is the side BC and the angle. And then we have the side M and the angle. So we can say here BC over what? Over sine 180 degrees minus beta plus theta is equal to M over sine beta. You see that? Okay. And then we can make B the subject, just multiply by this denominator there. And then we get that BC is equal to M and then sine 180 minus beta plus theta there. But we can reduce this. Remember that sine what? Sine, just remember, sine 180 degrees minus theta is in the second quadrant, isn't it? Is equal to sine theta. Just remember that. Okay. Right. You don't need to write everything here. I'm writing because I'm explaining. Okay. Right. So this means BC is equal to M, then sine beta plus theta over sine beta. So now we have BC, okay, using what? Triangle ABC. Okay, now we have to find BC now using triangle BDC. Okay, let's just do that. Right, triangle BDC is a right angle triangle, so we can use simple what? Simple trigonometric ratios. So if you check BC here is the side opposite the right angle, so it means BC is the hypotenuse. Okay, right now, and then P is adjacent to the angle theta there. So we can say that cos theta is equal to adjacent side over the hypotenuse. Okay, this is like over 1. Then you can cross multiply there and say cos theta times BC, that is BC times cos theta is equal to P times 1, cross multiplying this and this and this. P times 1 is P. We make BC the subject, so BC is equal to P over cos theta. Right, we're almost there. If you check, we have this right hand side there. So now this is BC, this is also BC. So we're saying M sine beta plus theta over sine beta is equal to P over cos theta. But here, remember what? Remember the compound angle. Okay, remember the compound angle. Sine beta plus theta is just the same as what? As sine beta cos theta plus sine theta cos beta. Okay, compound angle. Okay, remember that. And then over sine beta is equal to P cos theta. Okay, right. We'll meet when we're doing question 10D.